we're going to be reviewing, and hopefully this is a review, how to solve equations. So make sure that you are taking careful notes. An equation says that two things are equal. So guys, we've been working with expressions, and an expression doesn't have an equal sign, but an equation does, and it shows us that two things are equal just like a scale. So 2 plus 2, of course, is equal to 4. So what is on the left side, my 2 plus 2, is equal to what is on the right, the 4. So this is pretty elementary, and I know you guys are rolling your eyes, but we need a review. So what's a solution then? A solution makes the equation true. If you have a problem, your solution fixes it. So I need to figure out what's a solution for x plus 5 equals 7. This one's pretty easy, right? The solution would be x equals 2. X equals 2 makes the equation true. 2 plus 5 is 7. So you will be given equations like this, and I know that this one is really easy, that we can do it in our heads, but remember that we always start easy so that we can work up to those more difficult problems. So the first thing that we need to do is rewrite the equation. So we'll rewrite the whole thing on our paper. Once we've done that, we're going to draw a wall, and this helps us make sure that our equation is balanced. What I do on this side, I'll do on the other side, and here's my equal sign. The third thing that we have to do to be able to solve that equation is isolate the variable. So our poor little x needs some alone time. He's got to be all by himself. That means we got to knock this 3 off in some way. To be able to do that, we have to understand inverse operations to be able to isolate that variable. So this is like opposite day for math. Inverse operations are opposite day for math. We're going, or subtraction, sorry, this is just an example, is the inverse or opposite of addition. So if I have x plus 5, x minus 5 would be the opposite or the inverse operation. So let's practice just a little bit. And remember, inverse operations are opposite day for math. So the opposite of subtraction is, or the inverse operation of subtraction is addition. The inverse operation of multiplication is, of course, division. The inverse operation of division is multiplication. So back to our problem. We were needing to isolate the variable x. X needs some alone time. To be able to do this, I have to decide what's the inverse operation of plus 3 or a positive 3. The opposite of a plus 3 is going to be subtraction or minus 3. So I'm going to say minus 3. What I do on one side, I will need to do on the other. Minus 3. So my next step, of course, is going to just be solve for the variable and check the solution. When I solve, if I do 3 minus 3, that equals 0. We've just isolated our x. X is all alone. So x equals 10 minus 3 is 7. Well, let me get rid of this now. Okay. Oh, and I skipped a step. We've got to go ahead and check that solution. Does it work? It should. We said that x equals 7. So if I put in, if I substitute 7 for x, 7 plus 3, of course, does equal 10. Now, I know that this is elementary. I know this is easy, but guys, the thing about it is it's going to get tougher. So please go through every step. Let's go ahead and practice here. So I'm going to rewrite my equation if I was doing this on a piece of paper. Draw my wall. I need the inverse operation. So what's the opposite of minus 9? Well, it's going to be plus 9, right? That's a 9, if you were wondering. Oh dear. What I did on this side, I'm going to do on this side. Plus 9. Oh dear. So, negative 9, positive 9, eliminate one another. M equals 12. Sorry for the bad handwriting. And then we'll go ahead and see, is that correct? 12 minus 9 equals 3. Did I do it? Yay, I think I did. Okay, let's try this one. Draw your wall, make your equal sign. The inverse operation of subtracting is, of course, addition. This will help me get my j all by itself, plus 3. Now I just have the j equals. And I've got to remember to do my plus 3 here to keep my equation balanced. 4. Okay, let's try this one. Pause the video and see if you can do it on your own. So our steps are, draw our wall. Isolate the variable using the inverse operation. Opposite day for math, the inverse of adding 4 is subtracting 4. Again, I'm doing this to get my g all by itself. These two eliminate one another, leaving the g alone. I need to make sure that my equation is balanced. Since I subtracted 4 on this side, I will subtract it on this side. So if I have a negative and a negative, I'm just making more negatives, right? This is a making more. 12 plus 4 is 16. So now I have a negative 16. And I need an equal sign. Let's check this. Negative 16, that's a 6, plus 4 equals, well, now I have a war, don't I? Because I have opposite armies. I have a negative 16 and a positive 4. This is a war. That means someone must be eliminated. A negative and a positive, I will be subtracting. 16 minus 4 is 12, and it looks like my negative army won. So we have a negative 12. So, awesome. It looks like our negative 16 was indeed a solution. Let's try the very last one. Draw your wall. Determine your inverse operation, minus 5. What I do on one side, I'll do on the other, minus 5. I have C alone because 5 minus 5 got rid of that, and C is now isolated. 0 minus 5, if I have 0 and I take away 5, I still have a negative 5, don't I? Check your answer. Negative 5 plus 5, of course, equals 0.